A string is nothing but a group of characters which are enclosed in a pair of double quotation mark, and each and every string ends with a null character. A pointer can be a parameter. It works like a reference parameter to allow change to argument from within the function. Whenever you declare an array, it's going to reserve 5 space, 1, 2, 3, 4, 5, and last one is null character. Dear students, welcome to CS classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us continue our session with the topics pointers and strings, pointers and functions, dynamic and static allocation of memory, and invoking functions. Now let us cover these topics in this session. Now first we'll start with pointers and strings. Now you know what are strings? A string is nothing but a group of characters which are enclosed in a pair of double quotation mark, and each and every string ends with a null character. That is, you must remember that. So each string must end with a null character. Look at the example now. Here, array of 5 elements of a data type character. Now let us see the syntax of this declaration. Now here, character S of 5. So here, character is a data type and S of 5 is nothing but string array. So it is nothing but string. So here, character S of 5, it is an S is an array of character. And what is the size of? Size is 5. And if I say character star CPTR, so here this is a pointer variable, pointer constant. It stores the address of other variables. And CPTR equal to S, so it also represents character pointers to the string. So this is another declaration of characters and strings. Now the example, character S of 5 equal to hello. Look at this. This is character S of 5 is a string. We are assigning a string hello to the character array yes or string yes. Now in the string here, whenever you declare an array, is going to reserve 5 space, 1, 2, 3, 4, 5, and last one is null character. So here the first index is always in array, index start with 0. S is the name of the string or name of an array. So 0, 1, 2, 3, 4. So here S is a pointer to the memory allocation where H is stored. So here this S is, you are referring to the address of H, that is H here. So S of 0 refers to where H is stored. We are referring to the first index, that is S of 0. So E here S of 1, it refers to the memory space of for where E is stored. So similarly, it goes like this. Look at the example now. Here ampersand S, what is the AND stand for? It is address of operator. So ampersand S, it gives the address of variable or this index S of 0, that is H. If I say S of 0 is this one, if I say ampersand S means it gives the address of the H, that is the first index of an array. That is what you have seen in our previous slide. Next one is star S. Star S, it gives the H, the value of this variable or at the index, or it gives the content at this space or the value at this index. Next, S of 0 gives also H. So S of 0, obviously it gives the value available in that index S of 0, that is S of 0. And S plus plus, this is increment operator. So this is what you have learned. It is a pointer arithmetic. We can make use of plus plus, that's increment operator with the pointer. So S plus plus stands for, or it gives the address of the value E or the space where E is located or where E is stored. So this is increment operator. So it will be incremented by 1, value 1. So after 0, it goes to 1 index, index 1. So At S++, it gives the address of second index, the value of the second index. Next, star S++, as I told you, star is a reverse operator. It gives the content or the value stored in the index S of 1, that is E. So, this is pointers and strings. Next, pointer as a function parameter. Now, we have learned what are functions, and these functions are a group of statements, and a functions can have parameters or without parameter. A pointer can be a parameter. So what is the concept here? A pointer can be a parameter. It works like a reference parameter to allow change to argument from within the function. What is the concept here is, it is also possible to have a pointer variable as a parameter or as a function argument. Look at the example. Void swap is the function with the parameter int star x, comma int star y. So it is different from normal variable because a star x, star stands for pointer variable. So int ampersand x is a pointer variable. So in this function, we are passing the address, or we are passing the pointer variable as an argument. Next, inside the function, we have statements in temp equal to star x. This is the one way star x equal to star y, and star y equal to temp. This is the function, and here swap ampersand num1, comma num2 and semicolon. This is how we call the function, or this is how we invoke the function. And here, while invoking the functions, this ampersand num1, it refers to the first address of the, as you know, ampersand stand and symbol stand for address of operator. So ampersand num1 means it takes the address of the first variable, and num2, it takes the address of the second variable. So this is functions with the parameter or pointer variable as an argument. Now let us move on to next slide. And here, pointers and structures. So you know what are structures, what you have studied in your first PUC. So this is how we declare a structure. Struct is a reserved word, struct is a reserved word, and here student is name of a structure. And inside this, we have variables int, roll number, space. Next one is float, fees. These two are the variables, and the structures we are closing with semicolon. So this is, we are defining a structure. Now let us say student S, this is your structure variable. So we can say student is a name of a structure, and student S, here S stands for, it is a structure variable. And here, next one, student space star sp equal to ampersand yes. Now you know what is star sp. Star stands for a pointer variable, star sp, and ampersand yes. Ampersand stands for address of variable yes. So next one is, how do we access the structure variable here? Star sp dot roll number. So here star sp, this is the variable here, star sp dot roll number is one of the member of a structure here. We are accessing the member of a structure with this dot operator, and star sp is a pointer variable equal to 104. So this is pointers and structures. In the above, look at this example here. In the above statement, operator, we are using this operator as a pointer to member, and sp pointer to roll number, value equals to 104. This is an operator. We are referring with the pointers and structure. So this is how pointer, it is point to member, data member here. This is another operator to work with pointers and structure. Now let us move on to next slide. And here, memory allocation of pointers, there is dynamic and static memory allocation. Now, whenever we talk about pointers, and memory has to be allocated even for pointer variables, and there are two methods where we can allocate memory for a pointer variable. So here, one is static allocation of memory, second one is dynamic allocation of memory. These are the two methods where the memory allocation can be done with respect to pointers. Now let us move on to next pointer. Next concept is delete pointer. So memory that is dynamically allocated using the new operator. This is new operator. It can be freed using delete operator. So what is the meaning of this? Here, any memory, it is possible to allocate, dynamically allocate the memory is possible with the help of the operator new. New is an operator. So once the memory is allocated through new operator, it can be deleted or free with the help of delete pointer. The delete operator calls the operator delete function, which frees the memory back to the available pool. So delete pointer is used to free memory from the memory space. And next one is releasing dynamic memory. So here delete IPTR. Look at the syntax here. Delete IPTR. IPTR is a pointer variable. And to free dynamically array memory, delete, this stands for an array. DPTR is an array variable. And to free dynamic structure, delete student. Now we have seen in the previous slide, student, it was a structure, that example. So to free the memory allocated dynamically, it can be freed by using delete, and this is name of the structure, student. In this example, it is name of an array and it is a variable. So this is delete pointer. Next, let us see the definition of memory leak. What is memory leak? Here, if the objects that are allocated memory dynamically are not deleted using delete operator, the memory block remains occupied even at the end of the program. So sometimes when even with the help of delete operator, if it is not possible to delete the memory allocation, then those blocks or remains in the computer memory space. That is the concept of, or that is the condition is called memory leak. Such memory blocks are known as orphaned memory blocks. Means these are the memory blocks which are not deleted with delete pointer or delete operator. And these orphan memory blocks, when increases in number, it brings adverse effect on the system. This situation is called memory leak. And if the memory is not deleted and if it increases in numbers, more in numbers, is going to have adverse effect to the system, and this situation condition is called memory leak. So what is memory leak in general? We can say that, so it is a undeleted memory space which are allocated dynamically. Those are not deleted with the delete pointer or delete operator. If it increases in number, it will be having adverse effect to the system. This condition is called memory leak. Now let us move on to next slide. Next one is called free store or heap memory. Another definition, free store is a pool of unallocated memory heap given to a program that is used by the program for dynamic allocation during program execution. Now we know that what is dynamic memory allocation. Here the memory is allocated during program execution. So during that time, the few of the memory are not allocated for dynamic allocation. So those unused memory pool is called free store. So they are nothing but heap memory. Next concept is pointers and functions. And here to pass pointer arguments. Here what we have seen in our previous slide with the pointers and functions. Here it is possible to pass the argument to a function or to pass a pointer variable through a function argument. Here we are using asterisk when declaring the function and use the ampersand when calling the function. These things we have to remember. Look at this example here. So this is while use declaration we are using star, this is asterisk, and while calling a function we are using ampersand. This is what the meaning of the sentence what you have seen now. So here use the asterisk when declaring a function and ampersand when calling a function. Next one is invoking a function can be done by two methods. One is by passing the reference and by passing the pointers. This is how to invoke a function. These two are the different methods where we can invoke functions. One is by passing the references or by passing the pointers. Now let us see an example for invoking function by passing references. When parameters are passed to the function by reference, the formal parameters become the references alias to the actual parameters in the calling function. So this is nothing but when you pass the variables by reference method, the formal parameters, it becomes the alias or it becomes the reference to the particular variable while calling the function. This means that invoking the called function does not create its own copy of the original values, rather than it refers to the original value by different names. That is the meaning of reference. Here in point by reference method, whatever the value you are going to pass, it takes only the alias name, or by it works with the original data or the original value with different name. So any changes does not create one copy of it of original value. So it is going to work with the same value or original value with different name. So this is passing the reference or call by reference method. Now invoking function by passing the references here. So the called function works with the original data and any change in the values get reflected to the data. Passing by reference method, as it works with the original data, any changes made to the data is going to affect the original data. And the call by reference method is useful in situation where the values of the original variable are to be changed using a function. So this is call by reference method. Now let us move on to next slide. Here invoking functions by passing the pointers. So what is this concept here? See, when the pointers are passed to the function, the addresses of the actual argument in the calling function are copied to the formal arguments of the called function. So in the previous one, call by reference method or passing by reference method works with the original data with different name. But here with the pointers concept, here is going to pass the address of the actual parameters. So it's going to pass the address of the actual parameters. This means that using the formal arguments, the address of the original values is called the function. We can make the changes into the actual argument of the calling function. So here the called function does not create own copy of the original values, and rather it refers to the original values by addresses. So in call by or pointers or pass by pointers, in this concept, it is going to pass the address of the variable as an argument. So when you pass the address of the argument, it is going to work with the original data or original value. So any changes made to the data is going to affect the original values. But the only difference with the pointers and reference is that in point call by reference method, it works with the original data with alias name or with some other name. But in call by pointers or passing by pointers method, it works with address of the formal arguments. So any changes made to the data, it's going to affect the original data. This is passing the pointers. Next concept is pointers and objects. So here the pointers point to objects are referred to as a object pointers. Look at syntax now. This is class name space object pointer. Now you know how to create an object of a class. This is class name space variable name. So it is object. But here class name space star or asterisk object pointer. Class name is the name of a class and object pointer is the pointer to the object of this class type. So this is classes, pointers and objects. Now example, employee space I star EPTR. In this example, employee is the name of the class. This is name of the class. This is a pointer variable or it is an object here. So When accessing members of a class using an object pointer, the arrow operator is used. So instead of dot operator. So this is one of the difference. Here, this is, observe the star APTR is an object pointer because star indicates a pointer variable. So whenever you are working with this concept, here we are using this operator. This is hyphen and arrow mark instead of dot operator. So this is pointers and objects. Next definition is this pointer. So here every object in C++ has access to its own address through important pointer called this pointer. Now we know what is an object, and each object has an access to its own address through another pointer called this pointer. Please, I repeat once again, here any object of a class has its own object, has its own address. So object is going to access the address of his object by using another pointer called this pointer. So this pointer is an implicit parameter to member functions, and friend functions do not have this pointer, and because friends are not members of a class, only members of functions have this pointer. So this is this pointer. Students, let us continue our discussion in my next session. Thank you so much.